So, why on earth can't the world just agree on one plug? It's a puzzle that's baffled travelers for over a century. You pack your adapters, you hope for the best, but this isn't just about a chunk of plastic, no. This is about a deep historical feud in the very electricity that powers our world. Let's plug in and figure this thing out.
We've all been there, right? You land in a new country, you're all excited, you go to charge your phone, and you're met with this totally alien-looking socket on the wall. That little moment of frustration? It is a direct result of decisions made over 130 years ago, way before anyone even dreamed of a laptop or a smartphone.
At its very core, it really just boils down to this. In the Americas and some parts of Asia, the power zipping through the walls is around 120 volts at 60 hertz. But in most of the rest of the world, it's a beefier 240 volts at 50 hertz. So how did this happen? Well, the story kind of splits into two separate mysteries.
To really get this, we gotta solve two big mysteries. So, first up, the frequency feud. Why do some power grids have a heartbeat of 50 times a second while others beat at 60?
Okay, so what is hertz anyway? The best way to think about it is like the grid's electrical heartbeat. It's just the number of times the alternating current, or AC, flips its direction every single second. So 60 hertz means that current is doing a full back and forth cycle 60 times every second.
You have to remember, back in the late 1800s, this electrical heartbeat was all over the map. There was no standard at all. It was just this chaotic mess of competing systems. You had frequencies as low as 16 hertz, which would make lights visibly flicker, all the way up to a crazy 133 hertz. It was truly the Wild West of electricity.
The engineers at the time were facing a really tricky balancing act. See, to stop that annoying flicker in the early light bulbs, they needed a higher frequency. But for the big industrial motors and for sending electricity over long distances without losing too much power, a lower frequency was actually way more efficient.
So with no single, perfect frequency, the standard we have today was basically set by a good old-fashioned corporate rivalry. In the US, you had Westinghouse and the brilliant Nikola Tesla, and they landed on 60 hertz as the sweet spot for lighting and their powerful new motors. Meanwhile, over in Germany, the industrial giant AEG settled on 50 hertz, and as their business pretty much took over Europe, so did their standard.
All right, so that kind of solves the frequency feud. But what about the voltage? Let's dive into our second mystery. Why the world is split between roughly 110 and 220 volts. And this is where another giant of electricity, Thomas Edison, really enters the story. In this quote, it just sums it all up perfectly. While 60 hertz was an engineering call, the choice of voltage, well, that was all about business. So how did America get locked into 110 volts? It's a classic case of being the first to the party. Edison's early DC systems were incredibly popular, and all his light bulbs were designed to run on 110 volts. So when Westinghouse came along with his much better AC system, he made a huge business decision. He matched the 110-volt standard so he could tap into that massive existing customer base. By the time everyone realized the higher voltage was more efficient, it was just too late. The infrastructure was already built, and it was way too expensive to change everything.
Europe, on the other hand, started electrifying on a mass scale just a little bit later, and that actually gave them an advantage. They basically got to learn from America's experience. They saw the benefits of higher voltage, especially for sending power over long distances, and they standardized on 220 volts right from the get-go.
Now, it's really tempting to see this as a clean two-way split. America chose one way, Europe chose the other. But the reality, it was so much messier than that. The road to the standards we have today was anything but straight.
The chaos was absolutely real. Just look at North America in 1897. You had 25 hertz for the huge generators at Niagara Falls, 62.5 hertz from General Electric, all the way up to a blistering 140 hertz just for arc lighting. It was a total free-for-all, with different systems for completely different things.
And this legacy of chaos isn't just some dusty old history lesson. It's alive and well today in Japan, where the country is literally split right down the middle. The east, including Tokyo, runs on 50 hertz. The west, including Osaka, runs on 60. And why? Because back in the 1890s, Tokyo bought its generators from Germany's AEG, while Osaka bought its from America's General Electric, and they have been living with that one decision ever since.
So, after all these corporate rivalries, these technical compromises, and all these historical accidents, where does that leave us today? Well, we're left with a locked-in legacy that affects every single one of us, every time we travel.
So, after more than a century, you have to ask the crucial question, which system is actually better? And the simple answer is neither. Both 50 and 60 Hz systems work perfectly fine. Both 120 and 240 volt systems power our lives without a problem. They are just two different compromises that are now permanently locked in by 100 years of infrastructure and trillions of dollars in investment.
Which brings us to the final big question. We know why our plugs and grids don't match. But in a world that is this connected, this global, could we ever really see a single worldwide standard? Or are we just destined to carry a bag full of adapters forever?